Well, hello everyone. This is part 3 of the tension steel numbers. And since we solved a problem in part 2 about the net area, today we're going to continue on the uh, effective area. So I'm going to share with you 4 scenarios of how to find the effective area, more so of finding the shear lag factor, the U here, this value, the U. This is very important in finding the effective area. So we have 4 scenarios to be able to identify the U value according to the given information in a problem statement, if you will. So the first scenario, so again, just to remind you, every time you want to find these shear lags value, the U, is to come back to this lecture and read it through the 4 scenarios, and then you'll be able to identify the U value. So the first scenario is if we have a plate with bolted connections. If you have a flat plate and connected entirely to another area to transmit a load, then your shear load factor is 1, U equals 1. For bolted slide plates, the net effective area shouldn't be more than 85% of the gross area. In other words, let me grab my laser here. In other words, your effective area equals your net area, but both of those are less or equal than 85% of the gross area. In other words, if you find the gross area value, then you multiply it by 0.85, and this is your net area and effective area. But this is only for scenario number 1, which is a plate with bolted connections. Scenario 2, if you have a plate with welded connections, like the diagram here, the figure. So you have transverse weld, so you have a plate here with a connection. And the connection is a transverse, just in this way here. And then the second one is the longitudinal, where the connections is horizontally, as if you have the forces. Oh, let me grab my pen. Your forces are pulling in this direction and this direction, the same here. So then what happens? For the transverse weld, this scenario, your U equals 1, and your effective area equals the net area equals the gross area. In other words, if you find any of these values, then you find the 3 of them. But for longitudinal weld, which is this direction, I mean this situation here, then if your L is larger or equal 2 times the width, then U is equal 1. But if your if your L is less than 2 times the width and larger or equal 1.5 times the width, then U equals 0.87. And then if your L less than 1.5 times the width, then U equals 0.75. So if you're if you can tell, this is all an attempt of finding the shear value, which is the U, giving you different scenarios. Then you have the third scenario, where you have rolled section with bolted connections. Again, you have two cases where it's bolted and you have welded connections. So for all sections other than plates like HSS, then your U equals 1 minus X bar over L. And we call this equation 9.6. We'll need this, so you're gonna have to remember it probably. So what is X bar? X bar is the eccentricity, which means the distance from the centroid of the system to the connection. whether it's bolted or welded. And your L is, of course, the length of connection, right? If it's bolted, then it's from center to center. If it's welded, then it's going to be all the way around. So then, if you're not going to use the equation 9.6, which we just mentioned, then for angle-shaped single or double angles with 4 or more bolts in directions of loading, then your U equals 0.8. If the single or double angles 3 bolts in direction of loading, then it's 0.6 or 60. And then for less than 3, then you should use the equation 9.6. Then for other shapes, M, W, S, H, P, and T shapes, then for flange connected with a 3 or more bolts, then B, which is the width of the plate, is 2/3 of the diameter, and that gives you U.9. And the same here, if the B is less than 2/3 of the diameter, then U is 0.85. Then for web connected with 4 or more bolts, your U equals 0.7. And for all the other cases, your U equals the equation 9.6. Now, your fourth scenario for finding the effective area is the roll section with welded connection. So for transverse weld, U equals 1. And for the longitudinal and transverse load combination, then you're going to use equation 9.6. Let's look at an example here. This is example 9.2. So the equation, the problem statement reads, determine the effective net area for the single angle member in example number 1. So this is kind of in continuation of 9.1 after finding, and I have put example 9.1 here for you so we can refer back to it with all the information. And you find already that the area, the net area here, and they want us to find the effective area this time. So what is the effective area? The effective area equation is this. The net area times the U, the shear lag. So the net area, it's already found 3.71. Now I just want to highlight there is a typo in the textbook. The textbook uses 3.96, which is wrong. It should be 3.7 from our calculation here. So please correct that on your textbook. So now what is missing is the U. Now we need to find the U. How do we find the U? We need to use the 4 scenarios that we have just reviewed. We have 3 bolts, right? Because if we're going to use this mode of failure, the second mode of failure, right, this one here, then we have 3 bolts. So then if it's 3 bolts and it's an angle, if we go back to our scenarios here, we can read for single or double angles. Our case is single. With 3 bolts in the direction of loading, then our U equals 0.6 or 0.60. So then we go back here and plug everything in, and we find our effective value, effective area, and that's it. The problem is done. I think I'm gonna stop here. Thank you.